In today's video, we're going to find out why this system is better than a usual generator. The efficiency is more and the runtime is less. Now, I'm going to be showing you what I'm using here, so that at the end of the day, we're going to talk about them and I'm going to bring you back to how this system works. Now, this is a 13 horsepower engine. You can see it written on the body of the engine. So this engine can power a lot of things. It can run a mini sawmill, it can power a motor saw, 4-feet blade motor saw. It can do a lot of stuff. Now, most people actually use the 6.5 horsepower from videos that I watch. For some reason, I just decided to go for something big. Now, the reason why I did that was I will be needing power, like more consistent power, just in the event that my solar panels are not able to go through the night, and of course when it's a cloudy day. So that way this engine will step up and I'll use it to charge my batteries, and that way we'll be able to have power for business. The tank, as you can see right there, is about 4 liters, 1 gallon. So I think I'll need to check it out, but it's just somewhere around that range. And you can see this is the pulley. It has 3 pulley slots there. That means you can put 3 belts comfortably. Now, the project is about using this engine to drive a DC motor, and of course we know DC motors, they have different efficiencies depending on the kind of coil, magnet and everything that is inside. From videos that I've watched, the 6.5 horsepower engine can drive somewhere around 2.5 kilowatt load, or let's say motor. It can drive a 2500 watts load. So that's just about the limit I see. So if I'm using that as a case study, that means 13 horsepower should be able to drive almost 5000 watts load. The way this thing works is that this motor you see right here is a DC motor, a treadmill motor, of course. You can see a pulley attached to it. This is not how it came out. You want to put that pulley there. So once you connect this pulley to the pulley of this engine, what you have is that it rotates, and at the end of the day, depending on the RPM, this motor will be delivering full power. Now remember, this motor is 100% efficient. So the rating of this motor is 3 horsepower, which translates to about 2012 watts. So that way, let's say we can get 80% of the full capacity, we put it at somewhere 1008 or thereabout watts from it. So that means if I want to use this engine to drive it, I will not be maximizing the power of the engine. So that means I will either get 2 of these or get a bigger motor. This video is just for experimental purpose so that you understand how this thing works. The motor has a voltage of 180, that's DC. So what that means is that if I can drive it at the RPM that is stated there, which is about 4600, I'll be getting that voltage theoretically. Now what happens is that the voltage from the experiment I carried out, I noticed that there's always a drag. If the voltage you are feeding to your battery is low, it does not want to go past about 12 amps. Even if it's a 24 volt system, 36. I tried it to the batteries that I have. So that was the experience I was having. I am getting a charge controller, not because of this. I have been needing an MPPT charge controller for some time. I've already ordered for it, and this is what the MPPT charge controller looks like. So at the end of the day, what is going to happen is that when I'm experimenting this now, I'm going to connect this motor to the charge controller. I will make sure the voltage does not go past that 170, because the maximum voltage for this charge controller is 170. So what happens is that once I'm driving it at that full speed connected to my charge controller, it's not going to be shutting down the motor, this particular motor, and there's not going to be this drag, because there was drag when I was using it to charge my batteries directly. So I will not do that again. But what happens now is that once the engine is driving this treadmill motor, at the end of the day, instead of us to be using our generator to power the house, this is where the catch is. We are just going to be using all the power that is coming from this engine to charge our batteries. So that way, we are running this engine at full capacity and we are charging our batteries as best as we can. So there's no, we're underutilizing the generator. That's what usually happens if you're using the normal generator that you connect to your house, and sometimes you want to use it to charge your battery. It doesn't really charge very well, and you are going to be needing an external charger. So these are all things that you are going to be spending money on. So at the end of the day, with this kind of system, you don't need to connect it to your house. You just connect it straight to your battery, and your batteries will be receiving charge. Now remember, if I'm able to get a 4500, 5000 watts motor, most likely an alternator, At the end of the day, I can charge a 15 kilowatt hour battery in less than 3 hours, which is huge, because there's no other way you can charge that kind of battery with this kind of generator, even if it's a 13 horsepower generator you are using, because you will have to charge it through your inverter, which will not charge very well, and you may need to get external chargers, and by the time you go and combine all that load, you see that your generator is not working very well. And generally speaking, generators, they spoil chargers for whatever reason. So if you are depending on your generator to be using external chargers, it has a way of spoiling it very quickly. That's how this system works. What happens is that you are maximizing the full load of the engine and the motor that you're using it to drive. That's the sense behind it. For me, the advantage is that it is going to be more efficient because I'm using full power. I'm not going to use up fuel, so I'm going to be spending less money on fuel while I'm getting all the power I can get from my motor and my engine, and I am going to be running it for a lesser time. If I'm using 5,000 watts to charge my batteries, for instance, that should translate to somewhere around 100 amps or a little more. But if I'm using other means to charge it with the generator, there's no way you're going to hit 100 amps at 48 volts with your 13 horsepower generator. I think it's something that if you are living in an off-grid situation, your power is not constant and everything, it's something you want to try because it's very, very efficient. Now, the other catch is that since both of these systems are separate, the engine and the motor, they are not connected together as in a generator. One of the things that can happen is that if there's a problem with anyone, you disconnect it and take care of it. If it's a motor that's having problem, maybe it's too old or something, you can change it outrightly. So that way, maintenance is also generally cheaper for this kind of system. And if you get a very good motor, there are some wind generator motors that people use. So I watched a video like that. Those generators, they are meant to last well over 20 years. That's DC generators. In future, it's quite expensive though, but in future, if I can lay my hands on that, that would be like my goal, to use this engine to drive it. The efficiency is usually very, very high, and you're not going to have problem with it for a very, very long time. So see you guys and catch you on the next one.